In this talk, I would like to introduce how we use bottom-up view in the EasyView to help us identify the performance problems there. So the motivation here is that we found that most users still prefer the top-down view. While top-down view is really useful, but bottom-up view is also very powerful. So here, I would like to introduce how to use it. Okay, so here we profile a HPC application using HPC Toolkit. And now we can convert HPC Toolkit format into our EasyView format. Okay, so this application called Lulesh, which is a proxy application from the Lawrence Livermore National Lab. Okay, so let's see. We open this profile and we can see that we monitor the microseconds there. So it's just open the top-down view by default, right? From this top-down view, definitely we can see we have the program root because this is the main thread, and also we have the thread root because this is the OpenP threads. Okay, so that's why we have both the main thread and the working threads that sit together here, and also we can see the call path that's from the main thread or from the worker threads there. Okay, from the top-down view, definitely we can see some of the OpenP functions that can be the bottleneck here, right? But there's unless we know the program very well, we cannot really take any action for the optimization. Then we go to the bottom-up view to see that which function is called multiple times and consumed most of the time. Okay. So first we can see that there are some functions they called in two places. So this is because this is the OpenP function, and one is called from the main thread, another called from the worker threads there. Okay, and with one exception is this portion. Okay, so you can see that this portion we have a function BRK, which is called multiple places in the program. Okay, so BRK actually break, which is a system call that can handle the allocation, the memory allocation. So it's mapped back to the multiple places in the source code. If we can go back and see this related to the memory allocation and the memory release. Okay, if we can see that they are related to the allocation of the array somewhere that's in the code. Okay, so we can easily map back to the source code, and we see that this memory management can be a problem for performance. Okay, so so what we can do here is that okay, we can use a different memory management library rather than the default libc malloc, right? So actually we change this to the Google's TC malloc, which can yield 30% of the program speedup to the entire Lulesh code. Okay, thank you for your listen.